To build a website, you only need 3 ingredients: HTML, CSS, and JavaScript. That sounds pretty straightforward on the surface, but here's the problem. Nobody just uses HTML, CSS, and JavaScript to build a website. You might replace JavaScript with TypeScript, then throw in a UI library like React to replace HTML. You'll definitely need a CSS preprocessor like Sass. Then you'll need to import a whole bunch of third-party modules so you're not doing everything from scratch. Many of your dependencies might use CommonJS, which isn't going to work with your modern ES module syntax. The code will have name collisions all over the place, and even if you do manage to get it to work, you'll likely end up with a massive JavaScript file, which then needs to be minified and broken into smaller chunks just so people can visit your site with a reasonable load time. You'll also need to create different versions of your JavaScript and load polyfills to ensure that your code works on legacy browsers. As a developer, it's like being asked to land on the moon with a lawn chair and some balloons tied to it. It's truly the most annoying aspect of building a web application. But thankfully, we have module bundlers, which make this entire process a little less annoying. In today's video, you'll learn everything you ever wanted to know about module bundlers, like Webpack, Rollup, Parcel, and Snowpack. We'll primarily focus on Webpack because it's the most popular, but most of the core concepts that we'll look at apply to all of them. But make sure to watch until the end when we look at Snowpack, because it uses a technique that is much different than the others, and represents what I think will be the future of front-end web development. If you're new here, like and subscribe, and consider becoming a pro member at Fireship.io, or sponsoring me on GitHub for even more content. Let's start by answering the question of what is a module bundler. I already presented a long list of problems, and the role of the module bundler is to fix these problems. The most fundamental thing they do is take multiple JavaScript files and combine them into a single large file that can be then used in the browser to load your JavaScript app. This file, or the JavaScript bundle as it's called, contains your source code along with any third-party dependencies that you've imported. Your dependencies also likely have their own dependencies that need to be imported. A bundler like Webpack creates a dependency graph to keep track of how to put everything together. You just tell Webpack where to find your entry point, and it will look at all of your imports and dependencies and try to piece everything together into that single file. The best way to really learn how this process works is to do it yourself. Go ahead and open up VS Code, and we'll do everything step by step so you can follow along with this video. From an empty directory, create an index.js file in the source directory. Now currently, this file doesn't have any dependencies, so there's no need for a module bundler. We could simply run this file with Node or directly in the browser. Things get more complicated when we add dependencies like those from Node Package Manager. Run the command npm init flag y to create a package.json file. Now let's install the world's most dependent on JavaScript library, Lodash. When we run npm install, it adds Node modules here to the root directory, and then adds Lodash to the dependencies object in the package.json. Now what we want to build here is a front-end web application, so I'll create a public directory, and inside that directory add an index.html file. I'll add some initial HTML boilerplate, then in the head of the document add a script tag that references our index.js file. Now currently, our JavaScript code isn't using Lodash or any dependencies yet. If we view this file in the browser, you can see we get our hello world console logged here without any errors. But now let's go back to our code and see what happens when we try to use a dependency from Lodash. We'll go ahead and import the camel case function, and then camel case our console log. Now let's go back to the browser and try to view our website. You'll notice we get an error in the console. The reason we get this error is because the browser doesn't know how to resolve the Lodash code. In other words, you're asking it to find something, but it has no idea where to find it. And that's where something like Webpack can help us out. To use it, we first need to install it as a development dependency. We'll install the Webpack CLI along with Webpack itself. Now most often, when you bundle your production code, you'll use a script here in the package.json file. We'll give the script a name of build, and it simply calls the Webpack command. At this point, we can execute our script and run Webpack by entering npm run build from the command line. Webpack will analyze the code in our index.js file and then compile it to a dist main.js file, which is our production code, or the code that we would ship to the end user in the browser. So with that being said, let's go into our index.html file, and we'll change the path in our script tag to point to the main.js file. If we reload the browser, the error should be gone, and we should see hello world in camel case. Congratulations, you just bundled your first module. It's important to note that we're currently using the default Webpack config, and by default, it looks for the source index.js file. If your file's named something else, it won't work. In most cases though, you'll want or need to customize the behavior of Webpack, in which case you can create a Webpack config file. The file itself is a JavaScript module that exports an object that customizes the behavior of Webpack. Let's take a look at some of the most important parts of the object so you're not totally confused if you're the unfortunate developer who has to modify the Webpack config. The first attribute is entry, which defines the entry point to your application. In our case, that's the index.js file in the source directory. It's also worth noting that entry can be an object to support multiple entry points. You might see this used to support a technique called code splitting, so they're only loaded on the pages that actually need that code. It's beyond the scope of this video, but it's just good to know what code splitting means. From there we have output, which is the name of the file that we want to compile our JavaScript to. By default it's main.js, but we may want to change it to something else. And when determining the file location, we can use Node.js utilities like path to resolve a consistent path name. Now if we go ahead and run the build command again, you'll notice it outputs our bundle to a file called awesome.js. That's pretty straightforward, but you often have more to worry about than just JavaScript when building a full web application. Let's make things a little more interesting by adding an SCSS file to our code. Not only is this file not JavaScript, but it also needs to be compiled by the Sass compiler. We can make the file known to Webpack by importing it in our index.js file, but when we try to compile our code, you'll notice we get an error that says module parse failed. Currently, no loaders are configured to process this file. But what is a loader exactly? In Webpack, a loader is a way to pre-process a file. In our case, we want to import some CSS code, then tell our JavaScript to inject that CSS in the DOM when our web application is loaded. Essentially, loaders provide a way to handle any kind of file that's not plain JavaScript. Loaders exist for pretty much every use case you can imagine, including TypeScript, Markdown, and various CSS preprocessors. In our case, we're going to use 3 different loaders: Style Loader, CSS Loader, and Sass Loader. We can install these packages in our development environment, then we'll go back to our Webpack config, then add the module attribute. In this section, we can add 1 or more rules that will match a certain file type to the required loaders. The rule itself will have a test attribute that is a regular expression that matches any file that ends in .scss. When Webpack encounters one of these files, it can use the following loaders to process the SCSS into regular CSS and then to JavaScript so it can eventually be injected into an HTML page. Let's go ahead and save the config and then run our build command again. When we open the output, main.js, we can search through it and we'll find our CSS code embedded here. Loaders will likely do most of the heavy lifting for you in Webpack, but you can also tap into the Webpack compiler directly using its plugin system. A plugin allows you to tap into the entire compilation lifecycle. We're not going to build a plugin from scratch in this video, but we'll look at how to use one of my favorite open source plugins, the Webpack Bundle Analyzer. We can install it with npm, and it will tell us exactly how big our JavaScript bundle is and which dependencies are contributing to its size. In our Webpack config, we'll first import the Bundle Analyzer plugin, then we'll go down and create a plugins array and instantiate the plugin there. Now if we run the build command again, it will bring up this visualization of our JavaScript bundle. As you can see here, Lodash is taking up the majority of the space, and we can optimize that by only installing the actual functions from Lodash that we really need for the app. Now one annoying thing that we've been doing at this point is running the npm build command every time we make a change. Another way bundlers help you out is by setting up a local dev server to watch changes to your project and recompile them so you don't have to do it manually. First we'll use npm to install Webpack dev server, then we'll go into our Webpack config and use the dev server option to configure the files that we want to serve and the port that they should be served on. You can also configure the server for compression and hot module replacement. In any case, we likely want to add another npm script at this point. We'll go ahead and give it a name of dev, and it will run the Webpack serve command. If we go ahead and run that script with npm run dev, you'll notice it loads up a server on localhost 9000, and it will also watch the source directory for any changes and recompile anytime we save a file. So hopefully that gives you enough to get started with Webpack without feeling overwhelmed. Other popular module bundlers like Rollup and Parcel are very similar to Webpack, but try to achieve the same result with less configuration. Those are definitely tools you should be aware of, but what I want to focus on next is a relatively new bundler called Snowpack. One thing you might have noticed when we were using Webpack is that it took a while to compile all of our code. Each file change would take about 4 seconds to compile our CSS and JavaScript into a new bundle, and it can be a super annoying waste of time, especially on larger projects. Snowpack takes a different approach to handling modules and development. Instead of recompiling on every change, it builds all of your dependencies once and then ships them directly to the browser. That means when you make a change to your JavaScript code, it can be reflected in the browser instantly. Snowpack only needs to rebuild one file instead of going through the entire dependency graph. This is really awesome when you have a big complex project. because as your project grows bigger, your build times don't. They stay consistently fast. I've been using it for a personal project of mine, and the developer experience has been awesome, so I'd highly recommend checking it out for your next project. I'm going to go ahead and wrap things up there. If this video helped you, please like and subscribe, and consider becoming a pro member at Fireship.io for more advanced content. Thanks for watching, and I will see you in the next one.